Hello, everyone. Thanks for joining and welcome to another session of our Day One Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Now, our today's session is the Oracle Cloud Networking Quick Start, which will cover the key networking concepts within Oracle Cloud infrastructure, including virtual cloud networks, routing, gateways, and more. Now then, I'd like to introduce Ernesto Torres and Brandon O'Leary as our main presenters. And with that, I will hand it over to Ernesto.
Thank you, Borna. Good afternoon from Austin, Texas, and welcome to our OCI Networking Quick Start live webinar. My name is Ernesto Torres, and I am a cloud engineer on the customer enablement team. And I have the pleasure of leading today's session alongside my colleague, Brandon Larry. So we will be covering the following within OCI's networking services. So we will look into our virtual cloud networks. You'll often see these abbreviated as VCNs throughout the presentation. We'll look into subnets, route tables, the different gateway offerings, our peering options, VCN security, our load balancing service, and connectivity options. And by the end of this presentation, you should be able to understand the core networking services within Oracle Cloud Infrastructure, explain OCI VCNs and subnets, compare different networking gateways and their use cases, and be able to provision and deploy networking resources within your own tenancy. So let's get started. So this slide here displays an array of cloud services OCI offers, but today we're strictly focusing on our networking service here. And when setting up your networking in OCI, these are the main components of our networking services that you should be familiar with to properly configure your network's behavior. We will cover each one of these separately. First, we have here is our VCN, our virtual cloud network, and it is similar to a traditional data center, providing you with complete control over your cloud networking environments without having to deal with the underlying hardware. This is where all of your resources are going to be housed. We then have our subnets, which are basically subdivisions of a VCN acting as individual units of configurations. Our gateways enable traffic flow from one network to another. We'll go over the different gateway offerings as well. Our load balancing service provides automatic traffic distribution from one entry point to multiple servers reachable from your VCN. DNS stands for Domain Name System, and this service here translates human readable domain names to machine readable IP addresses. And then lastly, we'll cover FastConnect, which is our high speed, low latency, dedicated connection that allows you to access public and private Oracle Cloud services from your local infrastructure. So let's go ahead and jump into our virtual cloud network. So a VCN is set up in OCN in a particular region, and it is region specific. So it has the same functionality as a physical network on premise. So it comes with your traditional firewall, rules for traffic, and rules for security. I mentioned that it's region specific, and a region is basically a localized geographic area containing one or more availability domains. And this is what this AD is abbreviated as. So this is an availability domain. And these ADs are fault tolerant, isolated data centers within a region to achieve high availability. These ADs are separated enough from each other in the region that if one were to go down, let's say because of hardware or electricity issues, the others will pick up those workloads, making it fault tolerant and highly available. From a VCN perspective, it does reside within a single region, but it can cross multiple availability domains. This architecture diagram, just for simplicity, you only see one here, but most of our regions do have three ADs, and the VCN can expand through all three. And when you deploy OCI resources such as compute instances, the VCN is where they're going to reside. And this would enable communication with the internet, other instances, or your on-premises data center, like you see here in this architecture diagram. So each VCN has various components that are going to directly affect the behavior of the network, such as gateways, security lists, route tables, just to name a few. And we will get into these components here in the coming slides. Now, a subnet is a subdivision of a VCN. So you could see here that we have the VCN, this outer dotted rectangular box, and then the subnets are within the VCN. So a subnet can be availability domain or region specific. Regional subnets are recommended. That means that any resource that you create in subnet D for this example, you can allow OCI to select what AD that resource is going to fall into, or you could specify what AD you want. And this is really important because for AD specific subnets, so in this diagram, subnet A, subnet B, and subnet C would be AD specific, subnet D would be our regional. And so for AD specific subnets, if the AD that subnet resides in goes down, all of your resources will go down with that AD. Whereas with regional subnets, only the resources that reside in the AD that went down will go down, and you'll still have access to all of your other resources. Now, you can have multiple subnets in a single availability domain, but there is a 300 subnet limit within a single VCN, and each subnet has a contiguous non-overlapping IP space that is within the CIDR range of the VCN they reside in. So you can see here the VCN CIDR range is 10.0.0.0/16, and all of the subnet CIDR ranges reside within the VCN CIDR range. And we'll actually cover that in the next slide. So these subnets, you have the option of making them either private or public upon creation. And when you spin up an instance, it's going to be placed in one of these subnets. So it cannot just be floating around in a VCN. VCN houses everything, but an instance has to be placed within a particular subnet upon creation. And every instance will have a physical network interface card that we virtualize, and we call them VNICs. So you'll hear this term throughout the later presentation when Brandon covers security lists. A VNIC is basically a virtual interface card, a network interface card, which would be placed in a subnet of your choice. And then the instance will automatically draw their internal IP addresses from the subnets they're being placed in. Going over the VCN address space. So the first thing you do when creating a VCN is give it an address space. And a VCN covers one or more IPv4 CIDR blocks of your choice. And you can also enable IPv6 if you choose to. You can do it upon creation or after creation of the VCN. You can add those IPv6 if you choose to. So you could see here that the CIDR address looks like a normal IP address, except that it ends with a slash followed by a number. And the prefix represents, it's a representation of the network address in binary, while the suffix, so the /16, um, is the total number of bits in the IP address. So the number after the slash represents the number of addresses in the range. The lower the suffix in the VCN range, the more IP addresses are available. The allowable VCN size range in OCI is a /16, which is our largest. So this would be the largest size range, to a /30, which would be our smallest. In any of our CIDR blocks, the VCN is going to reserve the first two IP addresses and the last one in each CIDR. So a /16 is the largest size Oracle allows because it's generally sufficient for the number of nodes in a cluster, giving you a little bit over 65,000 network addresses. And this is enough for a cluster of up to 512 nodes. And a /30 is the smallest because this will only give you four IP addresses to work with. However, I did mention that the first two and the last one is automatically reserved. So in reality, you only get one IP address to work with. So again, the range is from a /16 to a /30. And we do allow the CIDR block to be modified once you create the VCN. If you think you aren't going to need all of the addresses, say you gave it a /16, you wanted to give it, you want to decrease the addresses to a /24, you can do that by increasing the suffix. Um, the suffix number after the slash, provided that you don't have any resources in the portion that you are reducing. So that's very important to keep in mind. So these instances use these IP addresses for communication, and they have at least one private IP address and optionally one or more public IP addresses. Each VCN automatically comes with the default route table, and these route tables have implicit rules, which include the routes for VCN siders. These routes have rules that look and act like traditional network rules, and each rule specifies a destination cider block and a target for any traffic that matches that cider. And the primary routing scenario is for sending a subnet's traffic to destinations outside of the subnet. And each subnet has a single route table associated with it. And all of the VNICs, those virtual network interface cards inside of the subnet, are subject to the rules in that route table. And these rules are going to govern how the traffic leaving the subnet is routed. So if no route rule matches the network traffic you intend to route outside of the VCN, that traffic is going to be automatically dropped. If the route table has overlapping rules, it will use the most specific rule in the route in the table to route that traffic. And one important thing to note is that if you don't specify otherwise, every subnet is going to use the VCN's default route table. However, you do have the option to edit or remove the default route table and add one that you've created after creation of the subnet. But just by default, it will take on the VCN's default route table. Now, shifting focus to gateways, um, here we start off with the internet gateway, and this is pretty straightforward. This provides a path for network traffic between your VCN and the internet. You can only have one internet gateway per VCN, and once created, in order to establish or enable traffic flow, you must add a route for the gateway in the VCN's route table, and the host on both ends of the of that connection must have public IP addresses for routing. So you could see here that the internet gateway is connected to this public subnet and not the private subnet because the private does not have or allow public IP addresses in it. So connections that originate in your VCN that are destined for a public IP address go through the internet gateway. And connections that originate outside of the VCN destined for a public IP address inside of the VCN also go through this internet gateway. Now, we also have something called a NAT gateway, and it's somewhat similar. However, this NAT gateway enables connections to the internet. It allows it to receive a response, but it's going to block inbound connections initiated from the internet. So this gives an entire private network access to the internet without assigning each host a public IP address. So you could see here in the diagram that the subnet connected to the NAT gateway is private, but the NAT gateway allows it to access the internet, get a response, but it's going to block inbound connections initiated from the internet. And this is possible because when a host and the private network initiates an internet bound connection, the NAT gateway's device public IP address is going to become the source IP address for that outbound traffic. And then the response traffic from the internet therefore uses that same public IP address as the destination IP address. And then that NAT gateway's device routes the response to the host in the private network that initiated that connection. So that's how these two differ. You still get access to the internet. However, the NAT gateway is going to block any inbound connections that have been initiated from the internet. And the biggest use case for a NAT gateway is to retrieve critical updates and patches. We also have a dynamic routing gateway. That's what the DRG stands for, dynamic routing gateway. And this gateway provides a path for private traffic between your VCN and destinations other than the internet, like your on-premises networks and connections between other VCNs, whether that be in the same region or not. You could use it to establish a connection with your on-premises network via IPsec VPN. And this will go through the internet through private traffic by using encryption. And then we also have your FastConnect option. And this is the product name of the digital circuit communication that provides a private dedicated connectivity. So, like your own HOV lane, there are performance gains there. However, it does come at a steeper price, but you get performance gains and security gains with the Fast Connect option. VCNs and DRGs have a one-to-one relationship. And one thing to note is that a DRG is a standalone object, standalone router, standalone gateway, however you want to see it. You can attach it to different networks that you choose to. So you create it outside of the VCN, unlike the internet and that gateway. You create them within the VCN. So if I were to terminate the VCN, the internet gateway and the NAT gateway would be terminated with it, whereas the DRG would not be terminated. You can deattach it and you can attach it to different networks if you choose to. The service gateway is the next gateway that we will be talking about, and this lets resources in your VCN access public OCI services such as object storage without using the internet or the NAT gateway. And object storage has public endpoints, which allows you to access a storage service through the web. And you would want to access object storage because when you take backups of your database, the best place to store them is object storage because it's built for this massive scalability and reliability of data. So if you have a private instance in a private subnet and you do not want to expose it to the internet at all, you can use the service gateway to connect to the object storage public endpoints using your instance private IP address. And this is all possible because it bypasses the internet and it allows your resources to remain within OCI's network backbone when communicating with the Oracle Services Network. And then lastly, we will look at multiple VCNs or connecting multiple VCNs through VCN peering. So we have two options here. We have a local VCN peering, which is the process of connecting two VCNs in the same region. So you could see VCN1, VCN2 are connected, and they're both located within region one. And then we also have remote VCN pairing, which is the process of connecting two VCNs in different regions. So VCN1 in region one is connected to VCN3 in region two using that dynamic routing gateway as well. So those are our gateway offerings. And having shown that, I'm going to quickly shift into the console to do a brief demonstration on our networking services. So this is the page you will land on when you log into the OCI console, and You can search anything in this search engine, and it'll take you directly to it. But I like to show you exactly where it is. So we have a networking tab here, and we are going to look into the virtual cloud networks. So I'll go ahead and click on that. And before you launch anything, deploy anything, you want to make sure that you are in the correct region you're planning to deploy in. Ashburn is my correct region. Sometimes I work in Phoenix, but whenever you create resources, you cannot move them from region to region. So you would have to terminate and create them again if you did that by mistake. So just make sure you're in the right region whenever you're deploying and in the right compartment. Now, if you have the appropriate identity and access management policies, you can move resources from compartment to compartment. That is doable. However, just try to deploy within the compartment that you're looking to do that in. And I'm in my specific compartment, so we're good to go. I want to show you two ways of creating a VCN. So the first one is the manual process. So this create VCN button is basically going to ask for some basic information. So you will give your VCN a name. This gives you a second time to make sure you are in the correct compartment, or if you want to modify or move it to a different one, you have a second chance to choose it here. I know I want to deploy here, and then you would just give it a CIDR block range. So just for ease of use today, I am going to give it a /16. And that's our biggest size available, or I could do a /30 if I want a small VCN with just one IP address to work with. I'll leave my DNS labels alone, leave it by default. And then we have here is our IPv6 prefix. So I can enable them at creation, or I can enable it after creation. I won't mess with that today, but that option is there for you. And then lastly, we have tags. So if you have a tagging schema already defined within your tenancy, then you can go ahead and apply your tags here as well. And lastly, we have a few security attributes too. But that's as simple as it gets. Once you have all this information ready, you would simply just hit create VCN. Now, doing it this manual process, you will create your VCN, but that's all you have. Just the bare VCN itself. You do not have any gateways deployed. You do not have any subnets. You have some route rules in your route table or in your security list that are automatically applied for troubleshooting purposes and a port 22 to SSH into your instances. But that's really it. You would have to go in and do everything manually and add all your stuff on your own. Now, if you want a if you want to bypass some of these steps and you want some of these to be created for you already, we do have a wizard, and there's two options when you create when you use the wizard. So you have an option to create with internet connectivity, and then also create um, with internet connectivity and site-to-site VPN. So it shows you everything that's going to be created. So here we have the VCN being created, we have a public and a private subnet being created, the internet gateway, NAT gateway, and service gateway. And then all of these route rules are already going to be automatically populated into your route table. You don't have to worry about that. It'll show you what gateway, what subnet is using what gateway. It'll give you all that information, so it's a quick out of the box environment that you can deploy by a push of a button. And then you also have the site-to-site VPN. So this is a bit different. Still the subnets, the VCN, except this one has a DRG with the site-to-site VPN to a customer premise equipment. I won't show this one because I don't have anything on premise to connect with, but I will walk you through what the internet connectivity looks like, which is the most common one people use. And again, it'll show you the architecture diagram and what's going to be included. So you would give it a name, the compartment you want it deployed in. The VCN is going to be, I'm sorry, the CIDR block range you would like to give your VCN. You can enable IPv6 here. And then your public and private subnet. So it's automatically going to name it based off the nomenclature that you gave the VCN name. So it'll probably be like public subnet VCN demo, and the same for private. However, you can change your CIDR block range for your private and public subnet. Just keep in mind that it has to be within the VCN's CIDR block range, and they cannot overlap. You do not want these to overlap, just to avoid connectivity issues. And then lastly, your tags. So if you have a tagging schema, this is where you would select those. And then below, once you hit next, you will basically get a review and create. You can see the VCN details, the public subnet details, the private subnet details, and then the gateways is going to create. So the internet gateway is going to be used by the public subnet, right? Because it needs the both ends to have public IP addresses. So it cannot be connected to a private subnet. And then the NAT gateway and the service gateway are going to be used by the private subnet. Below, you have your security list. So again, some generic troubleshooting ports and your port 22 to SSH. And then you have uh, two different security lists, one for your public subnet, and then this one is going to be for your private subnet. And then below that, you'll see the route tables. And security lists are going to be covered by Brandon here in a sec. So I'll let him explain what the process for this is and how they work. But those are already going to be there for you. And then the route tables for your internet gateway, and then also for your NAT and service gateway. And then you would hit create, and it'll be up and running within seconds. So I'll quickly show you what that looks like. I have one already created. So here is a details page of the VCN, your CIDR block range created, when it was created, the compartment, the OSID, which is the Oracle Cloud Identifier, and every resource you deploy has its own unique OSID. We also have IP administration. So this is where you can come in and add IPv6 if you choose to. This is where your subnets reside. So the public and the private subnet that was created, and they are both regional subnets. They're not AD specific. Here we have our gateways. We did not create a dynamic routing gateway, but we have the internet gateway, the NAT gateway, and the service gateway here. And then our route tables. So one for the public or the private subnet and one for the public subnet. Security. So we have our security list, again, one for our public and one for our private subnet. Network security groups, Brandon will cover here shortly, and our tags. So we have a tag default that's automatically going to apply some of these tags for us. If you know about tag defaults, you saw I didn't add any tags, but it tagged them for me. Um, I won't go into the details of that, but if you did tag your resources, this is where you would find them. Um, and the last thing I want to showcase is the DRG. So you see here it says create DRG attachment. So you don't create the DRG itself there. You would go under customer connectivity, dynamic routing gateway, and then you would create your DRG here. I already have one created. So once you create it, you can go back to your VCN and actually attach it through that attachment. So go here, go to my gateways, create DRG attachment. I will name the attachment, and then I will choose the DRG that I've already created. So if you didn't have one, you wouldn't have an option to choose one here. So you have to create it first, then come back, create an attachment, and then select the DRG that you created. So that's how DRGs work. And that is what I wanted to cover for our virtual cloud networks. I'll pass it over to you, Brandon.
Awesome. Thank you, Ernesto. Hi, everyone. My name is Brandon O'Leary. I'm also a cloud engineer here on the customer enablement team. And I'll be taking us through the second half of the presentation and another demonstration at the end. So next up, we have VCN security, load balancing, and connectivity options. Let's start out with VCN security. So when it comes to VCN security, you have your built-in firewall rules that are built into the networking service. You have your security lists and your network security groups, your NSGs. This slide right here, if we take a look at the topology, the shield on the corner of the subnet signifies a security list. And a security list is a set of firewall rules that is applied at the subnet level. And every subnet that you create, you'll have to assign a security list to it. If we take a look here at the right-hand side, you can see we have stateful rules. And what stateful means is that you're using connection tracking for any traffic that matches that rule. So in order to allow traffic into your subnets, you'll need to write or add adequate rules within that subnet security list. So when we have a stateful rule, that means you're using connection tracking. So the response will be automatically tracked and allowed back to the originating host. On the other end, we have the option for stateless rules. And if you mark a security rule as stateless, it indicates that you don't want to use connection tracking for any traffic that matches that rule. So what that means is that the response traffic would not automatically be allowed back out. So to allow the response traffic for a stateless ingress rule, you would need a corresponding stateless egress rule. Ingress is traffic going in to your subnet, and then egress is traffic leaving. We also have NSGs, and NSGs apply at the VNIC level. So here you can see, right, we have both network security groups and security lists, and they both act as virtual firewalls to control your traffic within your VCN. The fundamental difference is going to lie within the scope of application. So security lists are applied at the subnet level. That means that all of the resources within your subnet, such as virtual machines, databases, load balancers, within that given subnet are going to be subject to the same security list rules. And a good example of that here is on the left-hand side. So we could have a database, a virtual machine, two virtual machines, but all of the resources are going to be subject to the rules within the subnet security list. On the other side of it, we have NSGs, or network security groups. And network security groups provide more granular control by being applied directly to the VNICs of individual resources, or virtual network interface cards. So this allows you to apply different security rules to different resources within the same subnet. So as an example, in a multi-tier application, you could have separate NSGs for your web servers, your application servers, and your database servers, even if they all reside in the same subnet. So the best practice here is going to be to leverage NSGs where appropriate, because they're more flexible and they provide that granular control. And they allow you to decouple your application security requirements from the VCN subnet architecture, right? Because you're picking and choosing the VNICs that you want to apply the firewall rules to. So again, just to summarize, the main difference is that security lists are applied at the subnet level, and all of the hosts and instances within that subnet will have to adhere to those firewall rules within that security list. And then with NSGs, they allow you to get more granular, and you can assign the firewall rules at the VNIC level. So if you take a look here at our 10.10.2.0/24 network in the second VCN here, or subnet within the second VCN here, you can see that we're applying different sets of firewall rules to instances within the same subnet. Next up, we have load balancing. And load balancing is very important, and it provides automated traffic distribution from one entry point into multiple backend servers within your virtual cloud network. This will help you load balance large amounts of traffic, which could overwhelm a single server. And it also gives a mechanism to scale out an application tier by adding more servers, and also provides high availability for your applications. So if one of the availability domains has an issue, or some of the web servers on the back end, you can still be up and running in other availability domains. There's some different features and functionalities of the load balancing service that I can cover. First off is service discovery. So the OCI load balancers are going to perform service discovery by maintaining a list of backend servers within the backend set. You can also dynamically manage this list by automatically, adding or removing servers as needed from the traffic rotation. And as you update your configuration, or some of the servers become, offline or become available, they'll automatically be added or removed from that pool. Health checks. So this kind of goes hand in hand with the service discovery. The health checks are critical, and they're used by the load balancer to continuously monitor the availability of each backend server. So these checks are going to be configured for TCP or HTTP, depending on the server type, and they determine the health status of a server and automatically take unhealthy instances out of rotation to prevent them from receiving traffic. And then finally, we have a load balancing algorithms. So our load balancers offer several algorithms to distribute incoming traffic, including round robin, least connections, and IP hash. The policies determine how requests are routed to the available servers on the backend, and it helps you optimize resource utilization and application performance based upon your specific workload. Fault tolerance and HA. So by using a combination of the service discovery, the health check, and the algorithm, a load balancer can effectively route around a bad or overloaded backend. And again, as I've mentioned, if one of the servers is stopped on the back end, it would automatically be taken out of the pool. And then when you bring it back online, it would automatically be added back into the response pool. Scale. So within Oracle Cloud, our layer 7 or application load balancers have flexible shapes. This means that you can go in and set the minimum and maximum bandwidth, and then the load balancer can scale accordingly. This will avoid overload for any single resource. And then name abstraction. So this allows clients to access your application through a single stable IP address or DNS name. And then your backend servers don't need public IP addresses. They can use private IP addresses, and this enhances security by keeping them isolated from the internet, where the load balancer handles all traffic. So let's take a look at the topology or architecture diagram here. And we've added in a load balancer, and then we also have a backend set of web servers, right? And this can be a simple web server that's running, Apache, an HTML file. And if we take a look here, so traffic is going to come through and hit our primary load balancer, right, with this solid line. But let's say we have an availability domain outage, like a natural disaster strikes. When you're dealing with public load balancers and you have a regional subnet, it's going to be highly available by default. So that means a failover load balancer would automatically be placed in availability domain 2. And you don't need to worry or manage any of this failover or high availability configuration at the load balancer level. So in the case of an AD outage, if AD1 goes down, you can see the new path for traffic would be this dotted line here. So the dotted line would hit the failover load balancer, and then from there, it would distribute traffic among the servers within the backend set. We also have another type of load balancer, and that's going to be our private load balancer. So when you create a private load balancer, the service requires only one subnet to host both the primary and standby load balancers, but you can also host them in a regional subnet as well. And if you host them in a regional subnet with multi-AD region, that's going to provide failover capability. So it's going to be a similar setup to this, to where you would have a failover placed in a separate availability domain. However, if you create it within an AD specific subnet, it's not going to give you that failover capability in the response to an availability domain outage, right? Because AD specific subnets lock down the resources to a particular availability domain. So it is recommended for and useful for high availability to use regional subnets where you can. Oracle Cloud also has a DNS service. And with DNS, it's going to translate human readable domain names to machine readable IP addresses. A DNS name server is going to store the DNS zones and records and respond with answers to queries against its database. So when you type a domain name into your browser, your computer is going to query several DNS name servers until it finds the authoritative name server for that domain. The authoritative name server is going to then respond with an IP address and other requested record data, and then that answer would be relayed back to your browser, and the DNS record would be resolved to the web page. So there are some benefits here when running DNS within OCI. OCI is going to leverage a global network with numerous edge locations and employ anycast routing to direct user queries to the nearest DNS server. This is going to minimize latency, resulting in faster website and web application performance. High availability. So it's highly available internet-facing DNS, and the distributed architecture and built-in redundancy of OCI DNS ensures high availability for your domains, minimizing downtime even during server outages or other disruptions. The third point is scalability. So the service is highly scalable and it's capable of handling millions of queries per second, making it suitable for even the largest enterprises with high traffic volumes. It is secure, and there is built-in DDoS protection to mitigate large-scale attacks, maintain the availability of your domains. We also have other OCI security services that integrate seamlessly, like Web Application Firewall, Identity and Access Management, CloudGuard. These are some that enhance your overall security posture. We also have private DNS, and this allows for secure internal DNS resolution within and between virtual cloud networks, and even with on-premise environments. So it keeps internal information secure from the internet. These are some of the features of zone management within OCI DNS. So again, it's a highly scalable global anycast domain name system network that assures high availability and low latency. So when it comes to zone management, you have different features. You have APIs and SDKs that can be used to interact with the service. It supports secondary DNS. You can import and upload your zone files. You can filter and sort views of your zones and records, and you can create and manage your zones and records. And another service that goes hand in hand with DNS is traffic management and steering policies. So with traffic management and steering policies, it works together with DNS to intelligently route traffic based upon defined rules and policies. OCI's DNS service will manage the DNS zones, while traffic management steering policies enable you to create intelligent DNS responses by defining rules that determine which endpoints receive traffic. And these are some of those policies. So we have load balancer steering. You can set up round robin load balancing to distribute traffic among multiple servers. Round robin is essentially going from one server to another. So it'd be like server one gets traffic, server two, server three, server four, server five, and then back to server one, right? You can also set up weighted ratios via the ratio assignment. So if you wanted to test something out, bring a new server up or new host up, and you wanted to send 10% of traffic to that new server, 90% to the older server that you have that's already been tested, you can set up weighted ratios. Failover. So it's really easy to set up a simple active-active failover between two public assets. OCI is going to monitor the endpoints through health checks. And then in the event of a failure, it would reroute all traffic to a failover location. Geolocation steering. So this is important for routing traffic. If you're operating in multiple regions, you can set up traffic steering policies to route traffic based upon the source of the query, right? So if you have a large user base and you have users all across the globe, to reduce latency and have the lowest latency possible, you'd want to route traffic to the servers closest to the end user. So you can do this by leveraging geolocation steering to dynamically route requests to the appropriate response pool based on the physical location of the originating request. We also have ASN and IP prefix steering. So you can dynamically route requests based on the originating IP prefix or based upon the autonomous system number. Let's shift gears here and talk about connectivity options. So when it comes to connectivity options within Oracle Cloud, these are the three main connectivity options. So you have the public internet, you have our site-to-site VPN, and then you also have FastConnect. So with the public internet, you'll have 10 terabytes per month free of internet data out pricing. And then there'll be a low charge, if you exceed 10 terabytes per month. You also get reserved IPs and ephemeral IPs. With our site-to-site VPN, there's two main options, but it does provide IPsec authentication and encryption for the entire packet. So the two main options are going to be the OCI Managed VPN service or site-to-site VPN, and this is going to be free. And then we also have this software VPN. So you can run a software VPN running within one of your VCNs on an OCI compute instance, but you'll have to pay for the underlying compute resource. Finally, we have FastConnect. So FastConnect is going to provide you with private dedicated connection. It's going to give you that consistent networking experience. There's guaranteed port speeds available, and you get to choose your port speed, whether you want 1 Gbps all the way up to 400 in some regions, in some use cases. And there's SLAs in place, so service level agreements, and these are very important to guarantee, reliability, uptime, and consistency, and also speed. So let's dive a little bit deeper on the site-to-site VPN. So the site-to-site VPN is going to provide the IPsec connection between your on-premise network and your virtual cloud network. The IPsec protocol is going to encrypt IP traffic before the packets are transferred from the source to the destination, and then decrypt the traffic when it arrives. A site-to-site VPN, it was previously called VPN Connect or IPsec VPN, but we changed the name to a site-to-site VPN. Each of the IPsec connections are going to consist of multiple redundant tunnels. And for a given tunnel, you can use either Border Gateway Protocol, BGP, dynamic routing, or static routing to route that tunnel's traffic. Some of the advantages of going with the VPN over the other options that I've listed is that with public internet, that could be risky. It's not going to be, your traffic's not going to be encrypted. But with the site-to-site VPN, you're still leveraging the public internet lines to transmit data, and you don't need expensive lease lines like you would with FastConnect. The internal IP addresses of the participating networks and nodes would be hidden from external users, and the entire communication between source and destination sites is entirely encrypted, so it significantly lowers the chances of any information theft. All right. And then finally, we have FastConnect. So with FastConnect, there are two main options here. So again, this is your dedicated connection from your on-premise environment or from a third-party cloud. And like if you have a third-party cloud network in AWS or Azure, right, you can leverage FastConnect. But typically we'll see this with an on-prem deployment, and you can leverage FastConnect. It's going to give you that private, dedicated bandwidth with SLAs in place that guarantee uptime, availability, and speed. And it's essentially a dedicated line directly to what you have running within OCI. So when it comes to FastConnect, we have public peering and private peering. Public peering is going to be a direct connection to access public OCI services, such as object storage. So an example use case here, let's say you have a database on-premise, Oracle database, and you want to send backups securely over into object storage in the cloud, but you don't want to send those backups over the public internet. You could leverage FastConnect to send those, you'd have a dedicated line to send those backups into object storage. The other option is going to be private peering. So with private peering, you're establishing a dedicated direct connection to your private resources that you have running within OCI. On the VCN side, it would be connected to a DRG. And then on the customer side, you would connect it to your on-premise router. Within the cloud, that's represented as CPE or customer premise equipment. This will enable you to access your private resources, such as instances that you have running in private subnets or instances with private IP addresses, right, within your VCN. So those are the main two differences and the two options between public peering and private peering when we're talking about FastConnect. All right, so let's jump back into the OCI console and we'll take a look at the network visualizer. All right, so now you should all be able to see Oracle Cloud Infrastructure's homepage. So when you first get logged into your account, right, this is the main landing page that you'll be met with. You have your region selection up here. And as Ernesto mentioned, the VCNs are going to be regional by scope, right? So that means that they span all of the availability domains within a region. So if I'm in US East, I can see, what I have running there. Let's say I have another network in Chicago, then I can switch over and I can, manage that network over there as well. So with the click of a button, you can change regions and then you can manage the resources that you have within them. So back over to the demonstration. If we go over to the top left navigation menu, come down to our networking section, this menu here is going to have everything that we've talked about today within the session located here. So we have virtual cloud networks, load balancing, DNS, connectivity options, your site-to-site VPN, your FastConnect, customer premise equipment, IP management. You also have this network command center. So within our network command center, This is going to help you, and it's going to provide tools to visualize, monitor, and troubleshoot different areas of your network. We have visualization and dashboards like our network visualizer, inter-region latency. So you can, click on inter-region latency and you can see the latency in milliseconds between regions. We have our network path analyzer that can help with troubleshooting and diagnostics, and then also some tools like virtual test access points, capture filters for traffic monitoring. So for this demonstration, we're going to take a look at the network visualizer. And what's nice about the network visualizer is it can help you take a look at what you have running and how your networks are configured. So everything within OCI is going to be scoped by compartment when it comes to VCNs and the associated networking resources. So here you can see within this infrastructure compartment, I have many different VCNs created. So I'm going to zoom in and we're just going to focus on one virtual cloud network. But each hexagon here within the visualization is going to represent a separate network. So here we have our infrastructure VCN. You can see we have 3 different gateways on this VCN. And if it was peered to another network or connected to a dynamic routing gateway, you would see that reflected here in the visualization tool. This network is just a standalone network that we have running in Oracle Cloud 10.0.0.0/16. On the right-hand side, you'll see information about the resource. You'll see the OCID. OCID is like a unique identifier for a given cloud resource. So everything that you create within Oracle Cloud is going to have a unique OCID, whether it's a compartment, whether it's a virtual cloud network, a load balancer, a database, right? This is your unique identifier for your resource in the cloud. When we scroll down, we have a couple different resource map options, right? We have our routing map and our security map. So first, let's take a look at the security map. And this is going to show you all of the firewall rule sets that are attached at the subnet level and then also at the NIC level. So here you can see we have our security list here, and each subnet has a security list associated to it. If we had any NSGs in place, we would see those reflected here, network security groups. So when I click on one of these security lists, right, it takes me over, pulls up the resource summary, and then if I want, I can just click on the name. Let's say I want to modify some of these firewall rules. It's going to take you directly to that security list. And then you can begin, opening ports if needed, allowing ingress traffic if needed. We also have the routing map. So when you switch over to routing map, this is going to show the route tables, right, in a visualization. So here you can see how traffic leaving your subnets is routed. So we have a route for the internet gateway. And essentially this says any traffic leaving our public subnet is going to be routed through that internet gateway, right? If it's destined for any source CIDR or any destination CIDR, quad 0/0 just opens it up to any destination. So traffic that's destined for anything is going to be sent through the internet gateway. On the private subnet, we have a route for object storage and a route for any other traffic. So one important note here is with the route tables, it doesn't matter about the order of the routing rules. The route that's more specific is going to take priority. So in this case here, we have a route that says any traffic that's destined for object storage from our private subnet is going to be sent through our service gateway. This is going to ensure that our database backups, our virtual machine backups stay on Oracle's backbone, right? They're not going to be sent out to the public internet. All the traffic that is destined for object storage is going to be sent through the service gateway. Like I mentioned, the route that's more specific will take priority. So again, we have quad 0/0. This is saying that all other traffic that is essentially not destined for object storage, so all other traffic is going to be sent through the NAT gateway. So if we have a database in our private subnet, and we need a patch or a security update for that database. That database is allowed communication out to the destination, and it can receive the response back, but it cannot receive responses that have originated from the internet, right? And then finally, we have our resource map, our subnet inventory map. So if you click on this, we can see what we have running within the subnet. So we'll be able to see exactly what we have running. So within this subnet, we have 2 virtual machine instances, and this is our private subnet. So these are actually the backend set of a load balancer. And just some things to remember. So a VCN is that virtual private network that you set up within OCI. It's going to be your core components to all of the networking related services. Your subnets are subdivisions that you define within the VCN. So your VCN is going to be broken up into subnets. We have our built-in firewall rules at the subnet level called security lists. And then you can also set up your security rules at the VNIC level, which provides you more granular control over your security posture. And to do this, you would leverage network security groups or NSGs. Load balancing will help you distribute traffic across multiple servers in a backend set. And you can also connect to your VCN over the public internet through a VPN or through FastConnect. So with that being said, I'd like to thank you all for your time today. And I'm going to hand it back over to Borna, who will take us through a couple of slides here at the end.
Awesome session. Thank you, Brandon and Ernesto. Really appreciate your time and help with the session, and I hope it was a good learning experience for everyone. And now, if you want to learn more, if you enjoyed this session and would like for us to conduct personalized training sessions for your organizations, please do email us at our personal training email, and we will reach out to you. If you want us to conduct just a hands-on lab, we have a newly designed QuickShot Live Labs for more expedited hands-on learning experience for specific cloud topics. And also under the Code Innovate program, we can also co-develop solutions based on your own use case, as you can see here on the slide. Please remember the personal training program is an investment we make to our customers to help them grow and develop their OCI skills at no additional cost to them. And also, our next session will be Rethink What You Know About Enterprise Content on August 19th at 10 a.m. Pacific time, and we hope to see you then. Thank you all and have a good day, everyone.